When historians discuss the great conflicts of the 1940s, they focus on tanks, aircraft, naval battles, and strategic decisions. But there was another weapon, far less glamorous but equally decisive, that determined the outcome of countless battles. This weapon didn't fire bullets, it didn't drop bombs, it ran on steel rails and burned coal. The railway became one of the most critical strategic assets, and nations that mastered rail logistics often won battles before the first shot was fired. This is the story of how iron roads shaped the largest conflict in human history. It's about tonnage and timetables, about engineers and switchmen, about the unglamorous mathematics of supply that determined whether armies advanced or retreated, whether cities stood or fell, whether nations survived or collapsed. The railway was invisible in the sense that it rarely appeared in battle reports or news coverage. Journalists wrote about heroic charges and dramatic aerial combat. They didn't write about freight schedules and track maintenance, but generals knew the truth. Armies march on rails as much as they march on their stomachs. And the side that controlled the railways controlled the battlefield. To understand how railways became decisive in the 1940s, we need to go back to the previous century. Railways transformed warfare fundamentally and permanently. Before railways, armies moved at the speed of marching men and horse-drawn wagons, perhaps 15 to 20 miles per day, under good conditions. Supply lines stretched back along roads that became muddy nightmares in rain, dusty tracks in summer, impassable barriers in winter. Railways changed everything. Suddenly, tens of thousands of soldiers could move hundreds of miles in a single day. More importantly, the supplies to sustain them could follow at the same pace. An army that once required weeks to concentrate could now gather in days. An offensive that once took months to prepare could launch in weeks. The American Civil War demonstrated railway warfare's potential. The Union's superior rail network allowed them to move troops and supplies far more effectively than the Confederacy. Battles were won not just by courage and tactics, but by which side could concentrate the forces faster, via rail. Railway junctions became strategic objectives worth fighting and dying for. By the early 20th century, military planners understood that railways were essential infrastructure. The ability to mobilize armies quickly via rail could determine who won a war. Germany's Schlieffen Plan relied entirely on precise railway timetables to move millions of men to France before Russia could fully mobilize. When those timetables fell apart, so did the entire strategy. By the 1930s, Europe had the densest railway network in the world. Tracks crisscrossed the continent, connecting every major city and industrial center. This network was both a blessing and a vulnerability. It enabled rapid mobilization and supply, but it also created critical choke points, junctions, bridges, tunnels, whose destruction could paralyze entire regions. Different nations built railways with different gauges, the distance between the rails. Russia used a wider gauge than Western Europe. Spain had yet another gauge. These differences weren't accidental, they were partly defensive measures, making it harder for invading armies to use captured railways. But they also created massive logistical headaches when moving supplies across borders. Germany entered the 1940s with one of the world's most sophisticated railway systems. The Reichsbahn, the German National Railway, operated over 68,000 kilometers of track, with Germanic efficiency. Trains ran on precise schedules. Maintenance was meticulous. The system could move enormous quantities of men and material with reliability that other nations envied. German military planning integrated railways from the beginning. Every major offensive was built around railway logistics. Planners calculated how many trains per day were needed to supply an advancing army, how many locomotives were required, how much coal was needed to run those locomotives. They identified which rail lines needed upgrading to handle military traffic. The Germans created specialized railway troops, the Eisenbahntruppen, who were trained in everything from track repair to operating captured foreign railways. These troops could rebuild damaged track, construct temporary bridges, even operate on different gauge systems. They were engineer soldiers whose weapon was the railway. When Germany invaded Poland in 1939, railways played a crucial role. German forces advanced rapidly, but keeping them supplied required an equally rapid conversion of Polish railways to German use. The Eisenbahntruppen followed right behind combat units, repairing damaged tracks, rebuilding destroyed bridges, and establishing supply lines. The scale of railway logistics was staggering. A single infantry division required approximately 30 train cars of supplies per day just to maintain basic operations. An armoured division required even more, up to 50 cars daily. This meant that supplying a multi-division army required hundreds of freight cars moving every single day, like a river of steel flowing toward the front. Every tank, every artillery piece, every truck, every gallon of fuel, every round of ammunition, it all came by rail at some point in its journey to the front. Factories produced weapons, railways delivered them. Oil refineries produced fuel, railways transported it. The entire war economy flowed along steel rails. Germany's railways had one major advantage. They operated on home territory or in conquered regions with compatible infrastructure. German locomotives could run on French and Belgian tracks without modification. Supply lines from German factories to the front could operate smoothly. This logistical advantage was enormous in the early campaigns. But as Germany pushed deeper into Europe, particularly eastward, the railway advantage began to erode. The further from Germany's borders, the more vulnerable supply lines became. And when they invaded the Soviet Union, they encountered a railway system built on an entirely different gauge, a problem that would have catastrophic consequences. The Soviet Union possessed the world's most extensive railway network by total track length. The Trans-Siberian Railway alone stretched over 9,000 kilometers from Moscow to Vladivostok. Soviet railways connected the vast territories from the Baltic to the Pacific, from the Arctic to Central Asia. This enormous network was essential for holding together a nation that spanned 11 time zones. Soviet railways operated on a different gauge than European railways, 1,520 mm compared to the standard 1,435 mm. This wider gauge was deliberate. It made invasion more difficult because foreign trains couldn't use Soviet tracks without modification. It also allowed for larger, more stable cars that could carry heavier loads. The Soviet railway system was less sophisticated than Germany's in some ways. Trains didn't always run on time, maintenance could be inconsistent, rolling stock was often antiquated. But it had one overwhelming advantage: depth. There were alternative routes for almost everything. Destroying one line rarely crippled the system because traffic could be rerouted. Soviet railway doctrine emphasized resilience over efficiency. The system was designed to function even under attack, even with heavy damage. Railway battalions were trained to perform rapid repairs under combat conditions. They could lay track faster than any other nation's railway troops, using simplified construction methods that prioritized speed over perfection. When Germany invaded in June 1941, the Soviet railway system faced its greatest test. German advances were so rapid that thousands of kilometers of track fell under enemy control within weeks. But the Soviets immediately began a massive evacuation by rail, moving entire factories, millions of civilians, critical supplies eastward beyond German reach. This evacuation was one of the most remarkable logistical operations in history. Entire factories were disassembled, loaded onto trains, moved hundreds or thousands of kilometers east, and reassembled between July and November 1941. The Soviets evacuated over 1,500 major industrial enterprises by rail. Over 10 million people were moved eastward by train. The Soviets also destroyed railways as they retreated, denying them to the Germans. Bridges were blown up, track was torn up, locomotives were evacuated or destroyed. This scorched earth policy created immediate problems for German supply lines, which now had to rebuild everything while pushing deeper into Soviet territory. Soviet railway troops became legendary for their ability to construct and repair under impossible conditions. They built temporary bridges across major rivers in days. They laid new track in frozen ground. They kept supply trains running, even while under artillery fire. The railway became both a battlefield and a lifeline. Winter presented special challenges. Soviet railways were designed to operate in extreme cold. Locomotives had special heating systems. Switches had de-icing equipment. Maintenance crews knew how to keep things running in -30-degree temperatures. German railways, designed for more moderate climates, struggled terribly. Locomotives froze, water in boilers turned to ice, switches jammed. The Soviet winter waged war on German supply lines as effectively as Soviet soldiers did. The Battle of Moscow in late 1941 became partly a battle of railways. The Soviets brought reinforcements from Siberia by rail, moving entire divisions thousands of kilometers to defend the capital. German supply lines, stretched to breaking point and hampered by gauge differences and winter, couldn't keep pace. The railways helped save Moscow. When German forces pushed into Soviet territory, they immediately faced the gauge problem. Soviet railways operated on 1,520 mm gauge. German railways and rolling stock were built for 1,435 mm gauge. German trains literally couldn't run on Soviet tracks without modification. This seemingly technical detail became a strategic catastrophe. The Germans had three options: convert Soviet tracks to standard gauge, modify German rolling stock to run on Soviet gauge, or use captured Soviet locomotives and cars. They tried all three. Converting track was slow. Crews could convert perhaps 2 kilometers per day under good conditions. Modifying rolling stock was time-consuming and complex. Using captured Soviet equipment was limited by availability and the Soviets' thorough destruction during their retreat. The Eisenbahntruppen worked frantically to convert tracks. They developed efficient methods, removing one rail, shifting it inward, securing it at the new gauge. It was faster than replacing both rails, but still painfully slow. Behind the rapidly advancing front lines, a second battle raged, the battle to convert enough railway to keep supplies flowing. Initially, the Germans could manage. The front line advanced so quickly that supplies could still be trucked forward from railheads that weren't too far behind. But as the front moved deeper into the Soviet Union, the distance from converted railways to the fighting grew. Trucks consumed fuel, making long supply runs. Vehicles broke down on poor Soviet roads. The supply situation deteriorated steadily. Soviet roads were mostly unpaved. In spring and fall, they became seas of mud that swallowed vehicles. The Germans called it the Rasputitsa, the season of mud. During Rasputitsa, roads became nearly impassable. The only reliable transportation was rail, but if the railways near the front weren't converted to German gauge, supplies couldn't get through. The mathematics were brutal. A single railway line could carry as much freight as thousands of trucks. Converting one railway line was equivalent to adding thousands of vehicles to your logistics capacity. but conversion took time that advancing armies didn't have. The further and faster the Germans advanced, the worse their supply situation became. By late 1941, German supply lines were stretched catastrophically thin. Units at the front were running short of everything: ammunition, fuel, food, winter clothing. The railways couldn't keep up. Converted track existed, but not enough locomotives could traverse the vast distances. The few operating supply trains became critical targets for Soviet partisans. German generals sent increasingly desperate messages about supply shortages. Units were immobilized for lack of fuel. Attacks had to be postponed because ammunition hadn't arrived. Soldiers faced winter without proper clothing because supply trains couldn't get through. The gauge problem wasn't just a technical inconvenience, it was a strategic disaster that contributed to Germany's defeat. Soviet partisan groups specifically targeted railways. They blew up tracks, destroyed bridges, ambushed supply trains, and killed railway workers. German railway lines required constant protection, tying down troops that were needed elsewhere. Repairing sabotage track required men and materials. The partisans waged an effective campaign against German logistics. The gauge problem never really got solved. The Germans converted thousands of kilometers of track, but they never converted enough. As the front line stabilized and then began to retreat, the converted railways became less useful. They were now behind German lines, and the Soviets were reconverting them back to Soviet gauge as they advanced. Britain's railways faced different challenges. As an island nation, Britain didn't need railways for mobilizing against invasion. The English Channel provided protection. Instead, British railways became crucial for moving supplies from ports to where they were needed, for transporting troops to embarkation points, and for keeping the industrial war economy functioning. British railways were operated by private companies, coordinated by the government. The network was extensive and well maintained, though tracks were often single-line in rural areas. The system had evolved over a century to serve civilian needs. Now it had to adapt to military demands while still maintaining some civilian service. When men left to fight, women filled railway jobs. Female porters, ticket sellers, maintenance workers, and even locomotive cleaners became common sights. These women kept the railways running despite labour shortages, long hours, and difficult conditions. Their contribution was essential to maintaining the transportation network. Air raids created constant disruption. German bombers specifically targeted railway infrastructure, stations, tracks, marshalling yards, bridges. London's major stations were hit repeatedly. Railway workers developed procedures for operating during raids, for rapid repair of damaged track, for rerouting trains around bombed sections. The railways proved remarkably resilient. One of the most famous incidents involved St Pancras Station in London. A bomb penetrated the station roof but failed to explode, embedding itself in the platform. Railway workers and bomb disposal experts carefully removed it while trains continued operating on adjacent platforms. This was typical of the determination to keep railways functioning regardless of danger. British railways moved astonishing quantities of military cargo. Tanks arrived at ports and travelled by rail to training areas. Ammunition went from factories to depots to ports for shipment. Troops moved to embarkation points for deployment overseas. Food supplies moved from rural areas to cities. Coal moved from mines to power stations and factories. Everything moved by rail. The D-Day invasion required months of railway preparation. Troops, vehicles, ammunition, fuel, and supplies had to be concentrated in southern England without alerting the Germans to the invasion location. Railways moved these materials carefully, dispersing them to avoid obvious concentration that enemy reconnaissance might detect. The operation's success depended partly on railway efficiency and secrecy. British Railways also transported prisoners of war, moved evacuated children from cities to rural safety, carried salvaged materials for recycling, and maintained essential civilian services. The network operated at capacity, with trains running round the clock. Maintenance had to be performed quickly, often at night, to minimize disruption. American railways were different from European systems. Distances were vast. Transcontinental railways spanned thousands of miles. The network was built for freight rather than passengers, with heavy-duty tracks and powerful locomotives designed to pull enormous loads across mountains and plains. American railways were privately owned but operated under government coordination during wartime. The system was incredibly productive. American rail freight capacity exceeded all of Europe's railways combined. This enormous capacity became crucial when America became what Roosevelt called the arsenal of democracy. American factories produced weapons, vehicles, aircraft, and supplies in quantities that dwarfed other nations. All of this production had to move by rail, from factories to ports, from mines to factories, from farms to processing centers. The American railway system became the circulatory system of the Allied war effort. Consider the numbers. American railways moved over 90% of military freight. They transported millions of tons of steel, coal, oil, food, and manufactured goods every month. They moved entire army divisions from training camps to embarkation ports. They operated specialized military trains, hospital trains, prisoner transport, munitions trains that received special handling and security. Port cities became critical railway hubs. New York, San Francisco, Seattle, Los Angeles. These ports saw constant flows of military cargo arriving by rail and departing by ship. Marshalling yards near ports operated 24 hours a day, sorting freight cars, assembling trains, coordinating with port facilities. The integration of rail and maritime transport was essential for projecting American power globally. American railways also moved raw materials in unprecedented quantities. Iron ore from Minnesota's Mesabi Range traveled to steel mills in Pennsylvania and Ohio. Coal moved from Appalachia to factories everywhere. Oil moved from Texas to refineries, and from refineries to wherever it was needed. The scale of this movement was staggering. American railway engineering was robust. Bridges spanned canyons and rivers, tracks crossed mountains through tunnels and along grades that seemed impossible. Locomotives were powerful beasts that could pull 100-car trains across the Rockies. This infrastructure handled wartime traffic without significant expansion. It simply ran at maximum capacity. Railway workers became essential workers, exempt from draft in many cases because their jobs were too important. Locomotive engineers, maintenance crews, yard workers, dispatchers, they worked long hours under pressure. Accidents happened, but the system kept running. The American home front depended on railways as completely as the military front depended on supply lines. Specialized hospital trains evacuated wounded soldiers from ports to medical facilities inland. These trains were fully equipped medical facilities on rails, with surgical capabilities, nursing staff, and everything needed for patient care. They saved countless lives by rapidly moving wounded to proper hospitals. American railways also supported training. Vast training bases in the South and West received millions of recruits. These men arrived by train, trained for months, and departed by train for embarkation ports. Entire divisions, 15,000 men plus equipment, could be moved across the country in a matter of days using coordinated train movements. North Africa presented unique railway challenges. The desert environment was hostile to mechanical systems. Sand infiltrated everything, wearing out moving parts. Heat stressed metal and boiled water from cooling systems. Railways that existed were sparse, mostly coastal lines built by colonial powers for commercial purposes, not military operations. Both sides, Allied and Axis forces, struggled with railway logistics in North Africa. Ports were limited and everything had to come by sea. Once ashore, supplies had to move inland to where armies operated, often hundreds of kilometers across desert. Railways were the only practical way to move supplies in quantity. The coastal railway line from Egypt westward into Libya became a critical supply line. British forces relied on it to supply operations against Italian and later German forces. But the line was vulnerable. It ran near the coast where it could be attacked from sea and air. It had limited capacity compared to European railways. Maintaining it in desert conditions required constant effort. German and Italian forces faced even worse railway problems. Their supplies came from European ports across the Mediterranean, then had to move along inadequate Libyan coastal railways. British naval and air forces attacked these supply lines constantly. Axis forces in North Africa were perpetually short of supplies, partly because their railway logistics couldn't keep up with demand. Railway capacity determined what was possible operationally. Armies needed thousands of tons of supplies daily: fuel, ammunition, food, water in the waterless desert. If railways couldn't deliver these quantities, armies couldn't advance or even maintain their positions. Many North African campaigns stalled not because of enemy action but because supply lines couldn't support further advance. The Germans tried to improve Libyan railways but never succeeded adequately. Track was upgraded, but not enough. Rolling stock was shipped across the Mediterranean, but Allied attacks sank much of it. The fundamental problem remained. North African railways weren't built for military logistics on this scale, and there wasn't time or resources to rebuild them properly. The Eastern Front saw railway warfare reach its maximum intensity and importance. Distances were vast, armies were enormous, and supply requirements were astronomical. Railways weren't just supporting the conflict, they were determining it. Battles were won or lost based on which side could move supplies faster and more reliably. Soviet production centers had been moved east by rail during the 1941 evacuation. Now these factories in the Urals and Siberia produced tanks, aircraft, ammunition, and supplies in growing quantities. All of this had to move west by rail to the fighting front. The volume was immense, thousands of freight cars daily, moving in long trains across thousands of kilometers. Soviet railway organization was militarized. Railway troops operated with military discipline. Schedules were published and followed with surprising precision despite the chaos of the front. Trains ran 24 hours a day. Loading and unloading became highly organized. Specialized teams could unload a freight train in hours and send it back for more cargo. The Soviets became masters of rapid railway construction. They could lay new track at remarkable speed using simplified construction methods. When German forces cut a railway line, Soviet crews would build a bypass around the damaged section, sometimes in days. This resilience frustrated German attempts to interdict Soviet logistics. German railway operations on the Eastern Front grew increasingly desperate. As the front line expanded and then began retreating, German supply lines became impossibly stretched. The gauge problem never went away. Converted track required constant maintenance and was never sufficient for needs. Soviet partisans attacked railways constantly, requiring enormous resources to protect. Partisan activity was remarkably effective. Small groups could demolish track with explosives, derail trains, destroy bridges, and disappear into forests or villages. Germans had to garrison every bridge, patrol every kilometre of track, and escort every important train. These security requirements consumed manpower that was desperately needed at the front. The siege of Leningrad illustrated railway warfare's importance. German forces surrounded the city, cutting it off from overland supply routes. The only connection was across Lake Ladoga, by boat in summer and across the ice in winter. But the real lifeline was the railway, running to the lake's eastern shore. Supplies arrived by rail, crossed the lake, and entered the city. That railway kept Leningrad alive through 872 days of siege. The Battle of Kursk in 1943 became partly a railway battle. Both sides concentrated enormous forces, thousands of tanks, millions of men, vast quantities of ammunition. Moving these forces into position required railways operating at maximum capacity. The Soviets won partly because their railways delivered more supplies faster than German railways could. Soviet railway troops performed extraordinary feats. They built the Volga railway crossing at Stalingrad, while under constant bombardment. They constructed new lines to supply besieged cities. They maintained operations in conditions that seemed impossible: extreme cold, enemy fire, limited resources. The railway troops became unsung heroes whose contributions were as important as any combat unit. As the Soviets pushed westward in 1943 to 1945, they faced their own gauge problem in reverse. Entering Poland and then Germany, they encountered European standard gauge railways that Soviet equipment couldn't use. But Soviet railway troops had practiced gauge conversion and performed it rapidly, keeping supply lines functioning as they advanced. The final assault on Berlin required enormous railway support. Millions of artillery shells were brought forward by rail. Fuel for thousands of tanks arrived by train. Food for millions of soldiers moved on railways. The concentration of force that overwhelmed German defences was only possible because Soviet railways delivered the necessary supplies. All sides recognized railways' importance and targeted them for bombing. Railway yards, bridges, junctions, tunnels, these became priority targets for strategic bombing campaigns. Destroying railway infrastructure could cripple an enemy's ability to wage the conflict more effectively than bombing factories, because factories were useless if their products couldn't be distributed. Allied bombing of German railways intensified throughout the conflict. Initially, bombers targeted railway yards and rolling stock. Later, they focused on bridges, viaducts, and tunnels, infrastructure that was harder to repair quickly. The bombing campaign aimed to create a transportation crisis that would paralyze German military operations and industrial production. The results were mixed initially. Railways proved resilient. Bomb craters in yards could be filled and tracks relaid within days. Destroyed rolling stock could be replaced. The Germans became efficient at railway repair, mobilizing specialized teams that could restore service rapidly. But as bombing intensity increased, the cumulative damage became overwhelming. By 1944, Allied bombing was systematically destroying German railway capacity. Bridges across major rivers were repeatedly targeted until they collapsed. Railway yards were bombed so heavily that repair became impossible. Locomotives and freight cars were destroyed faster than they could be replaced. The German transportation system began to collapse. The oil campaign targeted synthetic fuel plants, but it also destroyed railways indirectly. Without fuel for trucks, railways became even more important. When railways were simultaneously being bombed into dysfunction, the compounding effects were catastrophic. German forces became immobilized for lack of both fuel and transportation to deliver what little fuel existed. The transportation plan before D-Day specifically targeted French and Belgian railways. The goal was to prevent German reinforcements from reaching Normandy quickly after the invasion. Allied bombers destroyed railway bridges, junctions, and yards throughout northern France. The campaign was brutally effective. German reinforcements that should have arrived in days took weeks. Strategic bombing of railways had a psychological effect beyond the physical damage. Railway workers faced constant danger. Operating trains became life-threatening, as bridges might collapse, yards might be bombed, stations might be attacked. This danger affected morale and efficiency, further degrading railway operations. Not all railway stories from the 1940s were about strategic logistics and military operations. The Burma Railway, built by Japanese forces using prisoner labor, represents the darkest side of railway construction, when human lives were considered expendable in pursuit of strategic goals. Japan needed a railway to supply their forces in Burma without depending on vulnerable sea routes around Malaysia. They decided to build a railway through jungle and mountains from Thailand to Burma, a route so difficult that pre-conflict surveys had deemed it impractical. But the Japanese military decided it would be built regardless of cost. The cost was measured in human lives. Over 60,000 Allied prisoners, plus approximately 200,000 Asian civilian laborers, were forced to build the railway. They worked in horrific conditions: inadequate food, no medical care, brutal treatment, tropical diseases, and punishing labor quotas. Approximately 12,000 Allied prisoners and 90,000 Asian laborers died during construction. The railway was completed in 1943, an engineering achievement built on human suffering. It operated for less than 2 years before Allied bombing made it unreliable. After Japan's surrender, much of the railway was abandoned. The human cost far exceeded any strategic value the railway provided. The Burma Railway story reminds us that railways, like any tool, reflected the values of those who built and operated them. German railways transported millions to concentration camps, an efficient logistics operation serving genocide. Japanese railways were built with slave labor and callous disregard for human life. Railways could serve evil as efficiently as they served legitimate military purposes. As the conflict ended in Europe in May 1945, a new railway challenge emerged: rebuilding destroyed networks to support reconstruction and recovery. The scale of railway destruction was staggering. Thousands of bridges were destroyed, tens of thousands of kilometers of track damaged, countless locomotives and freight cars destroyed. Germany's railways were particularly devastated. Allied bombing had destroyed approximately 40% of rolling stock. Bridges across major rivers were collapsed, yards were crater fields, tunnels were blocked. The network that had once been Europe's finest was in ruins, yet railway service was essential for recovery. Food distribution, coal transport, reconstruction materials all depended on railways. Allied military governments prioritized railway reconstruction. Engineer units worked alongside German railway workers to clear wreckage, rebuild bridges, relay track, and restore service. The first lines restored were those connecting ports to major cities, enabling distribution of food and supplies to prevent starvation. Soviet railways in liberated territories faced similar challenges. Retreating German forces had destroyed everything. Soviet railway troops began reconstruction immediately, following combat units and rebuilding as they advanced. By the time fighting ended, they had repaired thousands of kilometers of damaged railways. The reconstruction effort was remarkable for its speed. Critical main lines were operating within weeks of combat ending. Engineers used temporary bridges and expedient repairs to restore basic service, then gradually improved infrastructure. By 1946, European railways were moving more freight than in 1944, despite still operating with damaged infrastructure and reduced rolling stock. The conflict of 1939 to 1945 proved definitively that modern warfare depended on railway logistics. Armies that controlled railways could sustain operations. Armies whose railways were destroyed or inadequate faced defeat regardless of courage or tactical skill. This lesson influenced military planning for decades afterward. The conflict also demonstrated railways' resilience. Despite years of bombing, sabotage and combat damage, railways continued functioning. They could be repaired quickly, rerouted around damage, and adapted to changing circumstances. This resilience made railways both valuable and difficult to eliminate as strategic targets. Railway technology evolved during the conflict. Diesel locomotives began replacing steam in some applications. Specialized military rolling stock was developed. Railway operations became more sophisticated, with better coordination between military and civilian authorities. These advances continued into peacetime. The human cost of railway operations, both workers who maintained service under fire and forced laborers who built railways like the Burma Line, became part of the historical record. Memorial sites and museums preserve these stories, reminding us that logistics had human faces and human costs. Post-conflict railway reconstruction influenced economic recovery. Nations with functioning railways recovered faster. The Marshall Plan included significant railway assistance because planners understood that European economic recovery depended on restored transportation. Railways became symbols of reconstruction and hope. The strategic importance of railways declined gradually with the development of air transport, improved road networks, and eventually containerization and global shipping. But during 1939 to 1945, railways were irreplaceable. No other technology could move the quantities required over the distances involved with the reliability needed. The conflict drove railway technical innovation. Armored trains, used primarily on the Eastern Front, combined mobility with firepower. These trains carried artillery, anti-aircraft guns, and infantry in armored cars. They could quickly respond to threats along railway lines, though they were vulnerable to air attack and limited to where tracks went. Railway artillery reached its peak during this period. Enormous guns mounted on railway cars could be positioned along tracks, fire massive shells, and then quickly relocate. Germany's railway guns were among the largest artillery pieces ever built, firing shells weighing several tons. They required extensive railway infrastructure but provided capabilities no other weapons could match. Hospital trains became sophisticated mobile medical facilities. Fully equipped operating rooms, X-ray equipment, pharmacy, and patient wards all fit into specially designed cars. These trains saved countless lives by rapidly evacuating wounded from collection points to rear area hospitals. Some could perform surgery while moving. Refrigerated railway cars expanded in use, transporting perishable foods from distant production areas to consumption points. This capability helped feed armies and civilian populations. American railways particularly excelled at moving fresh produce and frozen meat across continental distances. As military railway equipment became standardized, the American S-160 locomotive design was mass-produced and shipped worldwide. These locomotives were simple, rugged, and could operate on various gauges with minimal modification. Hundreds served in Europe and continued operating for decades after the conflict ended. Communication systems advanced significantly. Railway dispatching became more sophisticated with better telegraph and telephone networks. Coordination between multiple trains on single-track lines improved, reducing accidents and increasing capacity. These advances carried over into peacetime railway operations. Track maintenance techniques evolved under pressure. Railway troops developed faster methods for repairing damaged track, replacing destroyed bridges, and clearing blocked tunnels. Some of these expedient methods became standard practice. The ability to rapidly restore service after damage proved more important than building perfect infrastructure. Rolling stock design adapted to military needs. Flat cars were reinforced to carry tanks and heavy equipment. Specialized cars were designed for ammunition transport, with safety features to prevent accidental detonation. Tank cars for fuel transport improved in capacity and safety. These military innovations influenced post-war freight car design. Behind every strategic railway operation, every supply train, every troop movement, were thousands of railway workers whose contributions were essential but rarely acknowledged. These men and women, locomotive engineers, conductors, maintenance crews, yard workers, dispatchers, station agents, kept the railways running under extraordinarily difficult conditions. Railway workers faced constant danger. They worked while under bombardment, during air raids in combat zones. Locomotive crews drove trains knowing that bridges might be bombed, tracks might be sabotaged, or enemy aircraft might strafe them. Station workers remained at their posts during attacks. Maintenance crews repaired damage while enemy forces approached. The casualty rates among railway workers were significant but poorly documented. Thousands died in bombing raids on railway yards and stations. Crews perished when trains were attacked. Maintenance workers were killed by unexploded bombs, collapsing structures, and accidents. These casualties rarely appeared in official records or histories, but they were real and substantial. Women filled railway jobs in unprecedented numbers as men left for military service. They worked as station agents, ticket sellers, porters, cleaners, and even in maintenance roles traditionally reserved for men. In Britain, women operated signal boxes and worked in marshalling yards. In America, women joined track maintenance crews. In the Soviet Union, women drove locomotives and worked as conductors. These railway women faced discrimination and skepticism initially, but proved their competence. They learned complex technical skills, worked long hours in difficult conditions, and maintained service despite wartime hardships. Their contributions were essential to keeping railways functioning with reduced male workforce. Railway workers in occupied territories faced impossible choices. Should they cooperate with occupying forces to keep essential services running, or resist and face execution? Many chose to resist through sabotage, minor delays, accidental damage, information passed to resistance groups. These small acts of resistance accumulated into significant disruption of enemy logistics. Some railway workers became active resistance members. French railway workers sabotaged German supply trains, provided intelligence about German movements, and helped Allied airmen escape. Their knowledge of railway operations made them valuable resistance assets. Many paid with their lives when discovered. The stress of railway work during these years was immense. Workers faced long hours, inadequate rest, poor nutrition, constant danger, and the knowledge that mistakes could cost lives. Post-traumatic stress wasn't recognized or treated, but many railway workers suffered the psychological effects for years afterward. After the conflict ended, railway workers faced new challenges. Networks were damaged, equipment was worn out, and traffic demands were enormous for reconstruction. They worked to rebuild what had been destroyed, often with inadequate tools and materials. Their efforts were crucial to post-conflict recovery. Railway workers' unions advocated for recognition and better conditions. In some countries, railway workers received special acknowledgement for their wartime service. In others, their contributions were overlooked in favor of celebrating combat soldiers. But the railways wouldn't have functioned without these workers, and the conflict couldn't have been fought without functioning railways. The legacy of these railway workers lives on in the restored networks they rebuilt, in the memories of those they helped, and in the understanding that logistics depends on skilled, dedicated workers willing to do difficult, dangerous work. They were the invisible force that kept armies moving, industries producing, and nations functioning. As we conclude this examination of how railways decided battles, we must remember that railways are not autonomous systems. They are operated by people, engineers and firemen in locomotive cabs, dispatchers coordinating movements, maintenance crews repairing track in all weather, station agents processing endless paperwork, yard workers assembling trains. These people, working under impossible conditions with courage and dedication, truly decided battles as much as any general or weapon. The Railway War of 1939 to 1945 was won not just by superior strategy or better technology, but by the millions of railway workers who kept trains running, despite bombs, sabotage, exhaustion, and fear. Their story deserves to be remembered alongside more celebrated military achievements. Without them, the great armies would have been immobilized, the factory's output would have been useless, and the outcome of history might have been very different. Railways decided battles, but people operated railways, and thus, ultimately, it was these unsung railway workers, as much as soldiers, generals, or politicians, who shaped the outcome of history's greatest conflict.